Section 7.2 is called Ratios in Similar Polygons. Okay, so the first thing we're going to do is talk about the difference between this symbol, which you should all know, called congruent, and a new symbol that we're going to learn today, which is just the wavy part, not the equal part, and it's called similar. All right, so when you see the congruent symbol, you know since the beginning of the school year, we've always talked about same size and same shape. Similar, we're going to have the same shape, but we're not going to have the same size. We're going to have what's called proportional size. Okay, so the last section we covered talked about ratios and proportions, right? Setting up a proportion, doing the cross product, and solving for the variable. Okay, so similarity, or two figures being similar, has to do with proportional size. Okay, so for example, if you have a small triangle like this, we'll call this figure 1. If you have the same shape, but just a little bit bigger or a little bit smaller, you would say that triangle 1 is similar to triangle 2. They're definitely not congruent, but they are proportional, so they are similar, okay? If you have a triangle like this, that's similar, almost like an equilateral triangle, and you compare it to a triangle that looks like this, we'll call this triangle 4, these are not similar. So triangle 3 is not similar to triangle 4 because it's a different shape. Even though they're both triangles, this one's more like a equilateral, this one's a right triangle. Okay, so they have to be the same basic shape. All right, so here's the kind of thing you're going to see. Example number 1. I'm going to give you a trapezoid. I'm going to give you some measurements. We're going to go 6 inches here, 5.4 inches over here, 4 inches up down here, and 5 inches over here. Okay, then we're going to compare it to another shape. Looks about the same, but we're going to compare with a similarity. Okay. So the second figure has 12 inches, 10.8 inches, 8 inches, and 10 inches. All right. So we want to know, are these two figures similar? And if so, we need to find their ratio and do something called writing a similarity statement. So on a similarity statement, you need to start at the same place and go the same direction. Unless it's flipped. And then you would go the opposite direction. All right, so you want to match up the sides. So notice from the first figure, you have 6 inches up here. What do you have up here? 12 inches. So from 6 inches to 12 inches, you do what? Double it, multiply it by 2. What about 5.4 inches to 10.8 inches? Double it. How about 4 inches to 8 inches? Double it. And how about 5 inches to 10 inches? Double it. So these are facing the same direction. Once in a while you'll see them flipped, but not very often. So we'll start with figure A, B, C, D, and we'll say that it's similar, and we need to match up A to E, B to F, C to G, and D to H. So we're going to say E, F, G, H. Okay. The next thing we're going to talk about is getting the similarity ratio. And so this is going to end up coming out a little different than what we just talked about. So if we start with the figure on the left, we're going to use side AB, and we're going to match it up with side EF. And AB is 6 inches, and EF is 12 inches. So even though from this figure to this figure, you would multiply by 2 to get here, this figure is actually half of this figure. So the ratio is actually 1 to 2. Wesley, take your headphones off, please. All right, now let's match up the right sides. So we'll have BC, and over here we have BG. So that's 5.4 to 10.8. We know that's going to be 1/2 as well. Then we're going to match up the bottoms. So we're going to say CD to GH. The left one is 4, the right one is 8. Also reduces to 1/2. DA to HE on the left, which is 5 to 10, which we know also reduces to 1/2. So our similarity ratio is 1/2. And you have to check all of them. All of the sides have to have the same similarity ratio. Yes?
You put BG instead of FG, yeah.
Oh. There we go. All right. So on similar polygons, you're also going to have congruent angles. While the sides are going to be proportional and they're going to have that ratio, the angles are going to be congruent because it's just shrunk, but the angle size is going to stay the same. So angle A is going to match up and be congruent to angle E. Angle B is going to match up and be congruent to angle F. Angle C is going to match up and be congruent to angle G. One more. Angle D is going to match up and be congruent to angle H. I'm going to lift this up. You'll see it in just a second. There it is. All right. Now, let's look at an example where they're going to have you compare 2 items. Okay. So the one we're going to talk about is a race car. So like a real life size race car and a model car. So like one you could hold in your hand. Okay. So I'm going to get real fancy and draw this amazing race car. It's beautiful. And then on the right, we're going to draw the model car. And they look exactly the same. You just have one bigger than the other. Okay? So on the left, the race car is going to have a measure of 1.8 meters across the front and 5 meters down the side. The model car is going to be 6.3 centimeters across the front, and down the side we need to find it out, so we're going to call it X. Okay, notice that both of these are in the same measurement. They're both in meters. So on the model car, these are both going to be in centimeters. So whatever number we get for X, it's going to be in centimeters as well. Sometimes you'll have to switch it, but in this case, since these are both meters, and these will both be centimeters. Okay, so we're going to set up a proportion. I'm going to use the 2 measurements for the race car as my ratio on the left. So I'm just going to take this one to this one, 1.8 to 5. And then I'm going to set that equal. And if I use this number in the numerator on this side, guess what? I have to use this number in the numerator on the right side. Yep, 6.63. Sorry. And the variable, the side we want to find out, will be in the denominator. Okay? Make sure you set your proportion up correctly. Okay? That's key. If you use the measurement from one item, in the numerator, you have to use the same measurement on the scaled down version. And sometimes it'll be turned or it'll be flipped or something. So just make sure you're comparing the right thing. So I'm going to do the cross product from here. I like my variable on the left, so I'm going to go this direction first, which means I'm going to have 1.8 times x, set that equal to 5 times 6.3. We're getting fancy with decimals, so I recommend use your calculator. So we're going to have 1.8x, and 5 times 6.3 is 31.5. And then the last step is the inverse operation of multiplying by 1.8, which is dividing. So I'm going to divide both sides by 1.8. I got 17.5, and the model car was in centimeters. All right, finish copying that down.